Hi, good afternoon. Uh, the idea of this short video clips is to introduce you the MATLAB programming. Some of you may already know what I'm going to talk about, but however, we just thought it is a good idea to take you through all the basic programming skills that you need in MATLAB. So what I'm going to do today is a brief introduction of the basic programming, what you can do in MATLAB, how to handle an M file, and then how to do basic calculations, basic plotting functions, what are the different types of plots that you can make, etc. And then there will be some sample programs uploaded in Moodle. With the screen capture program I'm going to use, I'll show you where they are located and everything. So what you are supposed to do is to listen to these short video clips explaining the purpose of each of those MATLAB files. Just post them just after I explain one program. Pause the video clip and then use the MATLAB file, run it, and get familiar with all the commands involved, and then continue again with the video file which explains the next M file. So let us go like that, and then I hope you will be able to handle all the basic things that you are supposed to know in MATLAB, which will be helpful for you to carry out the task 1 and 2 in project 1. Thank you. So I'll change over to the screen capture program now. Okay, here we go. First, let me take up Moodle site. As we go down in week 2, I have set up a link to a folder, MATLAB file for week 2. So in here, if you go in, you will see 1, 2, 3, 4, 5 different M files. I'll explain what are M files soon. So those are the files that you're supposed to download and run in MATLAB. And then let me show you how MATLAB starts. Where are we? Okay, so if you just look at your computer, yeah, and if you select MATLAB, this is how it starts up. I think on the other screen, so I'll just move it here. That's how the basic program looks like. This area is called the command window, and this shows the directory location, etc. And then this window shows the command history. So for us to work with already saved M files, the usual way to do it is to set the MATLAB path, which I am doing right now. So what I am going to do now is to go set the current working directory of MATLAB to the location where I have stored all the MATLAB files that I'm going to use, which have already been uploaded into Moodle. But now what I'm going to do here is to set the path of my MATLAB running on my computer into the location where I have saved those files in my hard disk. So that's the usual way of doing it. So I've set up a folder called MATLAB. So everything is in there. So these are the sample programs I will be using. Some of them, only the relevant files have been uploaded to Moodle. So now when you start off with a MATLAB program installed in any computer, MATLAB comes with the basic MATLAB, and then there are several other toolboxes depending on which kind of which subject area that you are working on. So as an example, to do control system analysis, they've got the control systems toolbox, and then if you are doing any optimization, you have optimization toolbox. If you are doing some communication related stuff, then you got the communication toolbox, and so on. So if you don't know what toolboxes have been installed in your version of MATLAB that is running on your computer, one easy thing you could do is you type VER on the command window, and if you enter, it will show you what has been installed on your computer. Excuse me. So in this case, we've got, this is the university version. We've got basic MATLAB, Simulink, communication block set, communications toolbox, control systems toolbox, fuzzy logic. MATLAB compiler is for compiling and downloading programs into some other devices, neural networks, optimization, real-time workshop, signal processing block set, signal processing toolbox, sim mechanics, sim power system, sim cap, etc. And then if you don't want these things to be on your command window, you can simply type clear and enter. Sorry, that's something else. Sorry, I forgot. You can go to edit, click edit submenu, and then clear command window. You can clear it, and then any basic computation you can do it right on the command window. Only thing is you won't be saving the outputs. Like for example, if I want to add 3 and 5, I can simply type 3 and 5 and enter. What MATLAB will do is it will assign that value 8 to a default variable called ANS, which stands for answer, right? But if you want to be a bit more organized, and then let's say if you want to assign the value 3 to a variable called A, you can type A equals 3 and enter. What happens if you just type A equals 3 and enter? The output, MATLAB will assign the value 3 to the variable A, and then it will show it on the command window. Alternatively, if you don't want that assigning to be appearing on the command window, you could add a semicolon to the right, and then if you type, number 3 will be assigned to the variable A, but it won't be shown. And then I can assign B with 5, and then I can say C is equal to A plus B. And then since I want the value to be appearing on the command window, I will just leave it without inserting a semicolon and enter. Then MATLAB will show that C is equal to 8. And then if you are interested in finding out what are the variables that are in the memory, current memory of MATLAB, you can simply type whos and enter. It will show all the variables. Like there is a variable called A in the system now. Answer is the one which we used earlier, B and C. And then if you don't want any of these to be in the memory anymore, one thing you can do is you can say clear and enter. Then it clears its memory. As an example, now if you type whos again and enter, you will see that there is nothing in the command window, nothing remaining in the command window, coming out in the command window. So this is how you could use your command window to do a basic like one-off type calculation. But then if you want a certain sequence of computations to be done repetitively, then this way of typing on the command window is not the best solution. Instead, we can use what we call as an M file. M file carries a sequence of commands, and it is saved as .m file, which can be executed. It is just like executing another program written in some other programming language. Then the file MATLAB, what MATLAB does is it executes all the commands in a sequence and then gives you the output. If it is a numerical value that is coming out, it can be on the command window as an output. If you want to make a plot or something, then it will appear, open up a separate figure window and send the plot data to that figure window, so that a graph will come out as the output. So with that, let me just take up the first M file. So you can open an M file like this. You go to File submenu, go to Open, and then ex_1 is the first file that I want to show you. So this is it. And let me just explain what I am doing here. First, I say clear. It is a safe thing to do that, because then what happens is it clears all the previous variables that have been in the MATLAB memory, because sometimes there can be situations where, particularly when you work with matrices and arrays, if you are using the same variable name, and that variable, if that variable had an array or a matrix of larger dimensions previously, all the elements of that variable or the matrix will not be deleted if you have reassigned that same variable with a matrix or an array of smaller dimensions. There can be some issues like that. So it is safer not to clear the memory before you run a new program. And then what I am doing here is I am assigning 1 plus 5, the addition of 1 plus 5 to the variable x, and then I am multiplying x by 7 and assigning that value to y. And this percentage sign is to denote the beginning of a comment, just like this syntax is more or less the same as what is being used in C programming or C++. Anything coming to the right of a percentage sign is a comment which is not executed. And comments are very useful when a second person is following up a program that is written by someone else. So it is good to make comments. Now, like here, I have put the comment that assign the value of x and so on. And what I have done here is I also wanted to find out what is x into y, x multiplied by y, and assign that value to z. But I have put a comment here, which means that will not be executed in the first run, but later on I'll show you the two difference between the two runs. When I take the comment sign off, MATLAB will execute that line as well. And then I am doing some other calculations here. A is equal to sine pi by 4. Pi, simple p, simple I, is used to denote 22 by 7, and the standard value of pi. So this is like sine of 45 degrees and cos of 45 degrees are assigned to A and B, and then C is equal to A squared plus B squared, of which the answer you know already. Like you can guess, sine theta squared plus cos theta squared is 1. So we should get 1 as the answer. So now I'll make this one smaller so that you can see the command window also in parallel, like this. And then I will perhaps first I will clear the command window, clear command window, okay, and then the program, here it is. So from this button, if I click it, it will execute the M file. So let's do that and see. Here it is. So as you can see, y has been assigned the value of 42, which is 7 into 6 is 42, which is correct, and then c is 1. And I'll have another run with the comment removed. So then I would expect y is 7, x is 6. So z equals 42 should come, I guess. Let's see. Oh no, sorry. Now what happened here is, as you could see, so y was assigned 42 as before, and then now it is a new value for y, right? So 42 into 6, 42 times 6 is the value of z. So that is how you got 252, and then as before the value of c is 1. So that is all about the first imp file. I think now you can stop the video clip for a minute and try to edit this program in the way you like and get more familiar with what is there. Let us start with the second program. I can just double click this to open it. So now in this one, what I am demonstrating is how to create an array or a vector of a certain variable, and then to plot a certain variation where our independent variable in this case is x. X in this case varies from -5 to 10 in 0.2 steps. This is how you create that such a vector. First you mention the lower limit, and then you mention the step size, and then you mention the upper limit separated by a colon. And then what I am calculating here is another vector y, which is 5 times x plus 2, and then you know that this is the equation for a straight line. What next? Then what I want to do is to plot these two variations. The corresponding command is plot x comma y, and then with plot there are several switches. By calling them, you can do whatever the configuration you like on the plot. So if you don't know the details of how to use any command in MATLAB, there is one easy thing you can do. You can simply type help and then plot, and if you enter, MATLAB will provide a help on the command window itself. So if you go up, the description for plot command is this. Plot is for linear plots, and then I'm not going to read through this. You can do it yourself on your command window. I just want to highlight these ones, like the switch blue is to have the points plotted in blue color, and these switches are to denote the plot type of the dots. What is the symbol that you want as each point, and then how these dots are going to be joined. Is it a solid or a dotted line or a dash dot, etc. So these switches, as I have done, can be called inside the plot command like this, with two inverted commas, inside two inverted commas. So now in this one the plot will appear in red with dots as points, and then third possibility we are not using that. And then also you can label them, or first the grid Once you plot it, the plot window, you can add the grid on it by calling the grid command. And then if you want to label x and y axis, you can use x label, y label commands, and also the title command. And then if you are interested in, let me comment of the rest and then run the first part for you, because I just want to show some of the features inside plot commands. So let's run this. Here it is. So here comes the output. As you could see, so these are the dots of the variation. X label has been labeled as x-axis, y-axis has been labeled as y-axis, and then the variation title is x versus y. So we keep it here, and I will open up this one. So what does it do? Now what we are telling MATLAB to do is first to plot this, and then we are asking MATLAB to plot another variation. Then let me show you what happens. Oh, sorry. I'll open up this one also. Then I'll show you what happens. So when I execute now, what happens suddenly? If you call a second plot command, what will happen is plot data of within that plot command will also be sent to the same figure window, but that will update the figure window. It will not retain the previous plot data, which is not the thing that we usually want, because we want to be able to plot more than one variation on the same plot window. If we want that to happen, then the way to do it is to open up this, call this hold on. We first plot one set of data, and then before plotting the second set of data, if we say hold on, then what MATLAB will do is it will hold the previous plot, and then on top of that it will add new plot data so that you can see both variations. Now I will shut this window down and run the program again. Here it is. So now this is the previous window, previous line, this is the new line. And then when you have more than one plots plotted on the same figure or the same graph, we would like to be able to add a legend describing what is each plot is all about. So that can be done by using this legend command. And in the legend, you have to mention the variations in the order in which you have plotted them. So first is variation of y, then it will show variation of y in front of a red dot, and then variation of y1 will be shown in front of a green dot or green point. Let me show that also. So I close it again, run it again. Here it is. So this is what I said. And how to manipulate any of these commands like legend, you have different switches that you can call with that to place it on a convenient location within this command window. Just type help legend on your command window and see. I'm not going to go into those details. Those are the things for you to do. Like, or else if you don't like that location, you can click and drag it to any location you want. And then if you are not happy with these axis ranges of the x and y axis, then there is this axis command. Here we mention the
lower and upper limit of x-axis first, and then lower and upper limit of y-axis next. So when I do this, just look at the ranges of default ranges of the x and y axis. Right now it is -5 to 10 in x-axis, -60 to 120 in y-axis. But now let me just run this program and show you what happens. Here it is. Now it has been set from -5 to +10 x-axis and -30 to +16 y-axis. So that is what we wanted. And since we generated the figure, I'll also show one thing before we uh, finish this one. Now, if generating a plot is fine, but we want that plot to be inserted, for example, on a Word file, for instance. There are a couple of ways of doing it. One is you can just go to edit, say copy figure, uh, and start your Word. Uh, Let me bring Word also to the screen. Start your Word. Now it is started, and you can simply say paste. Now the figure has been copied to your clipboard. So when I say paste, it comes. So this is the fastest way of doing it, but then the problem is you will have to keep writing your report in parallel to your execution of the MATLAB programs, which is perhaps not the most convenient way of doing it. Perhaps you want to be able to run all your M files first, generate all the figures you need, save them in some way, and then later on insert them on your document. So if you want that to happen, then there is another possibility. What you do is you just click on this one and then go back to your command window, and then there is a command called print, and there are some switches. What I am doing is I am just using the correct switch and then print this figure to a TIFF file and show how it can be inserted. But I invite you to type help print on your command window and see what are the all different possibilities. There are switches to save the figure with color, without color. So many options are there. So just have a look at it on your own. So I am sending this figure information to a TIFF file. The way to call it is print dash dtiff, and then I would say ex2. This should work. Right? As you can see now, this is my folder where all the files have been saved. Now you can see that there is a new file that has been created because of that command ex2.tiff. Now what I can do is I can go back to my original document. Right here I am going to insert the new figure. What I do now is go to insert picture, and then I go to my location where sorry, that's a mistake. T1 2012. Getting close. Yeah, here it is. ex2.tiff. Insert. So there it is. So you got the same one, but I think maybe the quality is better than just copying and pasting. Much better quality, and then you can reuse it. That's the most important thing. You don't have to do the report writing in parallel to running your M files. So that's the way you can save a figure generated from I mean a plot generated from MATLAB. So I think that's the end of second program. Again, pause this video clip, open up the program and play with it. Okay, let us start with the third program, ex underscore 3. Let us open it and see. This is a quick one. I just wanted to demonstrate one little feature, another additional feature in plot. Now when you just say plot, it will open up a default figure window which will be labeled as figure 1, and all the plot data that you keep on sending will be sent to that particular figure window. But instead, there can be situations where you would like to have data plotted in different figures. So if you want that, you can use this figure command, which will direct your plot data into different figure windows. As an example, in this case, y equals to 5 times x plus 2 will now be directed to figure 1, whereas y1 is equal to 10 times x plus 5 will now be directed to a separate figure called figure 2. That's the only new thing in this one. So let us run this and see. Yeah. So in this one there is a legend because of what? Let me see. There shouldn't be a legend coming in. Probably there was a figure which I couldn't close. Yeah, this is the way it should come, right? So figure 1 has red plot, which is the first line, and figure 2 has the green line, which is the second variation. So by this you can channel plot data to different figure windows. And one more thing, now let's say I want again send another set of plot data to figure 1. Then what you do is this. I'll just use the same equation to do that. So I recall figure 1. I don't need this one actually, sorry, that was a mistake. And then I say plot like this. Then what will happen is y1 is equal to 10 times x plus 5 will be sent to figure 2, but it will be resent to figure 1 as well. But for this to be effective, we have it already, but still it is better to hold on whatever it is there in figure 1 already by calling this hold on command. So now I'll shut these ones down, save this and run it again. Yeah, here it is. So first it plotted the red line, then it plotted this one, and then it plotted this one. So if you are not sure about what I am telling, another thing that we can do is we've got this pause command in MATLAB. You can insert that pause command anywhere you like if I say here pause here, what will happen is MATLAB will calculate these ones, plot them, calculate the points for y1 line also, but then it will pause. So to kick off MATLAB from pause, you just have to press enter, then it will execute the rest of the program. So we'll do one pause here and then another pause here, just to see how this sequence is ensured, sequence of plotting is ensured within MATLAB. So now when I run it, first figure appears. Now it is in pause mode. So then I enter, then comes the second figure. Now when I enter again, what will happen is this green line will again be plotted on this one. Let's see. Yeah, there it is. So that's how the pause command works. This, you can use this feature in order to execute the command, the program in steps. There are some other debugging features also, but this is one easy way of doing it. And that completes what I wanted to explain within the third program. Again, take a break, play with this program, and then you can start off with the other one. Okay, let's start with the fourth program. Let me see now. Is this the fourth? Yep, the fourth one. So this is to demonstrate another small feature within plot. There can be some other situations where you want two variations to be plotted on the same figure, but as two separate graphs. Then there is a command called subplot. Subplot divides the single figure window into an array, or like a matrix of plots. The way to define the number of subplots within the figure window is like this. Here we generate a set of data, plot data, and then subplot 2, 1, 1 means the plot figure window will be divided into 2 rows and 1 column of plots, subplots, and plot data will be sent to first plot window, and then these ones will be plotted, this data will be plotted on the first plot window. And then what will happen is we generate the second plot data, second set of data, and then we say subplot 2, 1, 2, which means those data will go to the second plot window, which will appear below the previous one, previous subplot. So we execute it, yeah, like that. So as you can see, first one, y is equal to 5 times x plus 2 is here, and then y1 is equal to 10 times x plus 5 is on this one. That's the little thing I wanted to explain in this program. And then within the same program, if you also wanted to send plot data to a second figure, that can also be done. So then what you need is, you should say figure 1 here, and then to separate figure 2, you could also send, let's say, the same set of data can be sent to a separate figure as well. So this will give me one figure window where there will be 2 subplots, and a second figure where y is equal to 10 times x plus 5 will be plotted on the full figure window. What? Oh, sorry, it must be simple, I think. This case sensitive. Yep, like this, right? So now you can imagine the way how you could manipulate this figure command and subplot command to channel your plot data into any different combinations you like. Yep, that's it.
So I hope you got something today about how to use some of the basic commands in MATLAB. There are some more MATLAB commands that I want to introduce to you, particularly related to control systems analysis. But without discussing some of the basic concepts like transfer function, uh, yeah, Laplace transform and transfer function, is a bit difficult for me to explain those commands. What is the use of those commands? So the arrangement for next week will be again there will be a short video explaining the basics of the concepts of transfer function, what is transfer function, how it is related to Laplace transform, etc. As I said, we are taking up those things again in week 6, but I think we need at least a short discussion for you all to be able to undertake task 1 and 2. Therefore, I am just advancing a little bit of discussions, but definitely the lecture will be there as planned. We will take up those concepts again in the lecture. So a quick video on Laplace transform, transfer function, etc., plus some more MATLAB commands, introducing some more MATLAB commands will be the focus for next week's workshop. So till such time you can work with whatever you have learned so far, and then let's meet during the lecture on next Tuesday. Thank you. Bye.